In this presentation we look at a special type of graph known as a complete graph. So what is a complete graph? Well, let's look at an example. So given Kn, which is the simple graph with vertices v1, v2 to vn, in which each vertex is connected to every other vertex by a single edge. The exercise asks us to draw k2, k3, k4 and k5, stating the number of edges in each case. Let's first off draw k2. Well, we have two vertices and each vertex has degree 1 and there's only one edge. So that's a simple case to start off with. Now let's look at k3. There are three vertices, v1, v2, v3, and for each of these vertices they all have degree 2 and the number of edges is 3. What we're going to try and do is derive a sort of rule based on the number of vertices and the degree, so that we can sort of come up with a rule-based system rather than just counting them out one by one. What I propose is using the number of vertices, and I'm going to call that, I'll get that new color, I'm going to call it n of v, number of vertices, by the degree of each vertex. Now the degree for each vertex is going to be the same for each vertex, all over 2. Now here we have 3 times 2 all over 2, and that gives us 3. Now you may ask, why are we dividing by 2? It's essentially because we count each vertex twice otherwise. Each edge, we will count each edge twice otherwise. So it's to stop that. Now we're going to do it for k4 and we're going to see if our rule works. So here we have k4. We have 4 vertices. Each vertex has degree 3 and there are 6 edges. So let's just double check now. So n is the number of vertices. Just change color there, black. N is the number of vertices and each vertex has degree n minus 1, and we're going to divide that by 2. So in this case we'll have 4 times 3 all over 2, which is 6, and we do actually have 6 edges. So this looks promising. Lastly, we're going to do it for k5. So here's an idea of what the graph would look like. We see that every vertex has degree 4, but you might sort of see it's a good bit harder to count now how many edges are there, so it's a good thing we have our rule. So the number of edges is going to be 10. So let's just double check that. 5, which is n, which is the number of vertices, times 4, n minus 1, which is the number of edges, the degree of at each vertex, and we're going to divide that by 2, and we actually have 10. So we should expect to see 10 edges. So we're actually, in this particular instance, we're going to count them. So this is 1, 2, 3, and 4. Now I'm just going to put the same names down elsewhere. 3 and 4. So 5, 6, and 7. This is 7 here again. This is 6 here. This is 5. And we're going to give this one the name 8. And we're going to give this one the name 9. So this is 8 down here as well. And this is 9. This new one here is 10. So that accounts for them all. So we actually do have 10 edges in this complete graph. So our rule works. So now we're able to do it for k6, k7, k8, k9. We'll be able to find out how many edges are in those graphs.